Okay, so when we left off last week, we were working on the date class, and we had written our increment function, but we still need to write the num days and month function before that's going to work, right? Just for the sake of review and getting us kind of caught up to speed a little bit, here's our client program. And so here's an example of what we want increment to do, right? We want increment to modify the calling object so that it is 1 day later than it currently is. Okay, and so we decided we could do that by incrementing day, and then if day is bigger than the number of days in the month, then we need to set day back to 1 and increment month. And then if month is bigger than 12, we need to increment the year and reset month back to January. So num days in month, I think I'm just gonna give you the code for that fairly quickly here. Don't hesitate to let me know if I need to slow down or you have questions. But num days in month is gonna return an int. And I'll just do it right here at the top. So there's a variety of different ways that you could set this up. I'm going to go ahead with, sorry, I might as well just make sure I follow my notes. Switch on the month. I'm going to do something that I almost never do in a switch statement. In fact, I think this may be the only switch statement I'll ever do this in. And that is, I'm going to have one of the cases. Most of the cases are very simple, but February is a little complicated. So I'm actually going to throw an if statement inside one of the cases. Normally, I would not want to do that. It can get messy really fast if your switch cases are too complex. But since it's just one of them, I'm going to go ahead with it. So case 2, if is leap year. Return 29, else, oops, return 28. So that's the complicated part of the num days and month function. The rest is pretty straightforward, I think. If it's April or June or September or November, and there's 30 days. Otherwise, there's 31 days. Okay. Any questions about the num days and month function?
Can you explain switch again?
Sure. Basically, switch just means whatever's here in the parentheses, compare that to each of the cases. So if month is equal to 2, execution is going to jump down to here and start with this statement. If month is equal to 4, execution is going to jump down to here and start with the next statement after that, which is this one. If month is equal to 6, it's going to jump down to here and start with the next statement after that, which is this one, and so on.
Got it.
Okay. Anything else? Okay, so we still have to write the is leap year function. I guess I didn't say anything about the fact that I'm putting the num days and month function in the private area of the class. That's just so that it's not part of the specification. We're not writing this function because we want the client to be able to call it. We are writing this function as a helper function for our increment member function. So we're going to put it in the private section of the class. Same with is leap year. Also notice that I don't need parameters in either of these, right? The reason I don't need a parameter in either of these is that I am answering the question for the calling object, right? So when I say, if day is greater than num days in month here, I mean, if day is greater than the number of days in month of the current calling object. So I don't need an argument. Same here with is leap year. Okay, so let's write is leap year. And we've seen that before, so I'm just gonna repeat what you've already seen here. Let's do that. Oops. If year modulus 400 equals 0. 1 equals 0. Oh, and then actually at that point, I can just say return year modulus 4 equals 0. All right. So I don't want to focus too much on the actual contents of the function here, since we've talked about it before, but if there are any questions about the classes part of this, how this all is fitting together, I'd be happy to spend some time talking about that. Anything we need to talk more about? I guess while you're thinking about that, I can go ahead and try this out. Num days in month. And 27. Wait, what? I didn't say it. Better. So I'm going to enter a date to 28, 1900. The date 1 does not come before date 2. That's correct. 1 day later, day 2 is March 1st, 1900. Okay. Any questions about any of this stuff? Okay. One more function I want to add. And then after that, I just have 3 sort of logistical pieces of information that we need to go over having to do with classes. And then we will be done with our intro to classes. So the one more function that I want to add to our class is going to be an increased by function. So here's how we would call this function from main. Okay, so hopefully this gives you the idea. Hopefully you can look at this code and determine by looking at the code what the increased by function is supposed to do exactly, right? And basically, I'm going to take a date and I'm going to advance it by 12 days, or whatever the argument is, right? So we need to take into consideration the possibility that someone may call increased by, and the argument there might be 10,000 or something like that, right? But whatever the argument is, we're going to advance the date that many days, but we're not actually going to modify the calling object. What we're going to do is we're going to return the calling object. Okay, so that's an important distinction, and it's an arbitrary decision, and I made the opposite arbitrary decision that I made with the increment function, right? With the increment function, I said, okay, let's make this a void function. It doesn't return anything, but it modifies the calling object. Now I'm doing the opposite. I'm saying increased by should not modify the calling object. It should return an object that is equal to the calling object increased by the argument. Okay, so I could have said, no, you know what? Let's just have my increased by function modify the calling object. So I would have just said date to dot increase by 12, and then that would have modified the calling object by advancing it 12 days, right? But I decided to have it return a value. So now just to sort of beat this idea to the ground a little bit, the difference here is analogous to sort of the difference between, let's say I've got an int I can say I plus plus, and I can say j gets I plus 12, right? So with the increment operator, what we do is we aren't looking for the return value, we're looking for it to actually modify the calling object. With the plus operator, we do not modify either of the operands, rather we return the result, right? So I'm kind of doing the same thing here with my increment function, modifying the calling object, and my increased by function, not modifying the calling object, but instead returning the result. All right, any questions about what the increased by function should be doing? Okay, let's go write our prototype for the increased by function. But first, let me ask, what type of value is increased by going to return? So, and let me say that anytime I give you a client program and I say, okay, now you write the class, figuring out the prototype for the member functions should be automatic. Everything you need to know to determine what the prototype is going to be is right here in the function call. So tell me what the return type of the increased by function is going to be.
Date.
Date. I have one vote for date. Any other votes? It's another vote for date. Okay. So let's go through the process here, right? This line here, line 146, is an assignment statement. That means I've got an assignment operator. I've got an object on the left side. I've got an expression on the right side. Those two things have to be the same type. The types have to match, right? So since the object on the left side is of type date, that means the expression on the right side also needs to be of type date. since the expression on the right side is simply a function call, that means that that function is going to have to return something of type date. Okay, so that should be pretty automatic. Let's go make my prototype here. Return type is date. Name of the function is increased by, and then I have an argument or a parameter. Okay. Any questions about how we got that prototype? All right. Now let's write the function definition. So I'm gonna I'm gonna go over the process of writing the function header in excruciating detail, so please bear with me. But let me first of all provide a template for how you are going to write your header of every member function you ever write, okay? It's gonna be return type, space, name of class, colon, name of function, and then parameters. Okay, that's my function header. That shouldn't be surprising to anyone, right? Everyone okay with that? Everyone see how this template matches the header file we did here? Got the return type of bool, name of class is date, colon, name of function, and then in this case, no parameters. Okay, so here's the pattern for you to follow. So in our current situation, what is the return type for increased by? Okay, date, that's correct. The return type is date, space, name of class. What's the name of the class? Date, right. Colon, name of the function, parameters. Okay, any questions about that? Whoops, increased by. Any questions? Okay, how are we going to write the code then that goes inside? Let me take a shot at it and you can tell me if you guys like this or not. How's that? Never mind, my brain turned off there just for a second. That is not what I meant. I meant day plus equals num days. There. How's that?
I think that's correct.
I'm sorry, one more time.
I think that's correct.
You think this is correct? Anybody else have any other thoughts? Or anyone else agree with that? No comments. All right, well, there are actually, as it turns out, there's a couple problems with this. Anybody want to help me identify what the two problems are that I'm seeing? Or just identify one of the two? Return statement at the beginning of line 30. That's not going to help us much. So the part of your answer that is correct is, yeah, we're missing a return, right? This is a value returning function. We're supposed to return something. However, just putting a return there, that's not going to help us much because what we need to return is a date. And this line of code is saying to return an int, right? So if we try to compile this, we're going to get a syntax error saying, wait a minute, this function says that it's going to return a date, but it's returning an int.
I think we should call a set function,
We should call the what function?
the set function, because like the day, for example, like day plus day equal day plus num days can be greater than 30 or 31. So we have to fix this problem too.
Okay. I still missed the very first part of your statement though. You said we should use the which function? We need to call the
set
set
set.
function.
Yes.
I'm not saying that it's impossible to solve this problem by calling the set function, but I'm not sure how that's going to help us. Let's do this first. Before we try to solve the problem, tell me what the problem is. What's the problem with this? Well, so I told you one part of the problem, right? We need to return a date object, right? As a matter of fact, let me say it this way, okay? So here's out of the two problems we need to solve. Problem number one is we're not supposed to modify the calling object. This statement modifies the calling object, right? We're not supposed to modify the calling object. We're supposed to return an object that is equal to the calling object advanced num days times.
Can you repeat one more time?
This function is not supposed to modify the calling object, right? If we look back in main, this function call, we don't want to change the value of date 2. So we don't want to change the value of the calling object. We want this function to return a date object that is equal to date 2 plus 12. Right. Okay, so not sure if somebody can articulate what's confusing about that statement, please feel free. So let's put it this way. What I need to do here is I need to have an object that I can return. So I'm gonna declare a new date object. Okay, and then I'm gonna set that date object to calling object plus num days. Okay, I'm using the word plus there loosely. I hope everyone understands what I mean, right? I'm just saying, instead of saying advance it by num days, I'm just saying plus num days, right? I hope that is sort of intuitively understandable, but if not, please let me know. And then once I have set result equal to the calling object plus num days, then I can return result. Does that plan make sense? This is like a sort of a mix of real code and pseudocode, but you should be able to look at that and understand how that's going to solve this problem. Anybody want to say that makes no sense at all, or that does make sense, or? Okay, no comment. I'm going to take silence to mean we're good, just keep going. Let me just, I guess I'll just make another observation about this. This is actually a pretty common pattern that you'll see in value returning functions, right? In lesson 8, we had a power function that returned an int. And it was something like int power, int base, int exponent. And basically the way we did that is I said int answer, and then there was some other code in here. And then at the bottom, I said return answer, right? So this pattern really has nothing to do with classes or objects or anything like that. If this makes sense, then this should make sense. Okay, so does this make sense? Because if not, I could maybe, would it help if I just wrote out this whole function or not? Anybody want to see that?
Yes.
Okay. So this would be, I'm going to start off answer equals 1, and then I'm going to say for int I gets 0, I less than exponent I plus plus answer, multiply answer by the base. Okay, so in other words, the way we would say that loosely in English is we would say we're multiplying base times itself exponent times, right? And so by the time I finish that for loop, answer is the correct value that I want to return. And so I'm just going to say return answer. Okay, and so we're going to do something very similar here. We're declaring the variable that we're going to eventually return. We're setting that variable equal to the right thing, and then we're returning it. Okay? So unless anybody objects, I think I'm going to delete this. I guess I can just comment it out for now. All right, and then let's go back to this. So I said there were two problems with just saying day plus plus. One was that we need to return a date object, right? So if that was the only problem, then that means that I could now just say result. I'm going to set result to month, day, year. Okay, so that makes it so that result is now equal to the calling object. And then I would just say result.day plus equals num days, and then return result. Any thoughts or comments or questions about that? Let me put it this way, actually. I want to get a sense of how many of you are with me now. And so what I want to say is that if, first of all, let's get rid of this. If we don't have to worry about the day crossing over into a new month, right? So as long as num days is small enough so that we're just staying within the same month, this code will actually work perfectly. Anybody want to say whether you're with me or not at this point? So if, let's say that date 2 is January 10th. January 10th, 2020. Okay, if I increase that by 12 up here in my increased by function, I set the result equal to the calling object. So now the result is, wait, now I can't remember what day I said. January 10th is what I think I said, 2020. And then I'm going to add 12 days to that. That's just going to make it January 22nd, 2020. And then I can return that. Done. Any questions? Anybody want to, okay, good. Anybody want to articulate what the problem is that we still have here?
That if it was at a later date, or if we wanted to increase it by a bigger number, then instead of saying February whatever, it
Right.
would say January like 30 or something.
Right, or January 40th or 50th
Yeah.
or something, right? Yeah, okay, exactly. This doesn't work if we cross over into the next month. So how are we going to fix that?
You could use a for loop and instead use increment.
Okay, so that's a good solution. Before we go there, let me just make sure everyone gets that if we don't use the increment function right now, we have a mess on our hands, right? Because if num days is like 10,000, how are we going to keep track of, increasing, advancing the date by 1 year and then subtracting 365? But if it's a leap year, we have to subtract 366. And then what if we're halfway through the year? So it would be a mess. So since we already have this increment function, it turns out to be very nice. We can just say, hey, let's call the increment function num days times, right? So we're going to set the result equal to the calling object. And then we're just going to have a for loop. It goes num days times. And each time through the for loop, I'm just going to say increment. I'm sorry. I'm not changing the calling object. I'm changing the result, right? Result dot increment. Then after the for loop's done, I'm done, and I'm just returning the result. Okay. Any questions about the increased by function? Okay, so I'm going to test this out. Let's see, I'm going to enter, let's say, February 27th, 1900. 1900 is, well, I'm going to just hit enter. So 1 day later, date 2 is February 28th. And then if I add 12 days to that, because 1900 is not a leap year, adding 12 days to February 28th should give me March 12th. And so that's correct. Okay. If I did the same thing with the year 2000, which was a leap year, 2/27, 2000, then I should get March 11 instead of March 12, right? Okay, and so I think that's working the way we want it to. Any questions about increased by? Any objection to me deleting this? So by the way, in your assignment for this week, you're going to have to do something similar in the sense that you're going to declare an object, a local variable object in your member function. You're going to set it to what you need to set it to, and then you're going to return it. So this is going to be a pattern very similar to what you're going to see in your assignment. Okay, so if there are no other questions about the increased by function, I'm going to move on and start talking about those three logistical details that I mentioned before. The first one that we're going to talk about is something called constructors. A constructor is a function that is automatically called when an object is declared. Okay, so sometimes it helps students to kind of get the historical perspective on this, why we would need a constructor. Sometimes, in order for a class to function properly, there are certain things that need to be set up for every object. And we're not actually going to see that this week, but we're going to see that not next week, but the week after, 2 weeks from now. We're going to see a situation where if we don't set things up correctly when a date object, when an object is declared, the class isn't going to work, right? Back in the old days, before object-oriented programming, if we were going to try to do something like this, we might have to say, okay, Mr. or Mrs. Client Programmer, you can use my date class, but every time you declare an object of type date, you're going to have to call this function that I'm providing called initialize first before you do anything else, right? And then at some point, somebody said, hey, wait a minute, why don't we just make it so that the class programmer can write a function that gets called automatically, and so the client programmer isn't responsible for calling that initialize function. All right, I don't know if any of that made sense. It was the objective was to help you understand the motivation for constructors. If you got lost, don't worry about it. But let me just, so we're going to see this in action very shortly. But before we can actually write a constructor, I need to tell you the 2 rules for actually creating a constructor. To create a constructor, you have to do 2 things. There is no return type. Okay, so when you're going to declare a constructor just like any other member function, but when you declare it, there's going to be no return type. That doesn't mean void. That means that when it comes time to type the return type, you leave it blank. So there's no return type. Same name as the class. Okay, so let me go ahead and illustrate those 2 rules by creating a constructor right here in my date class. Rule number 1 is I'm not going to type a return type. So I'm just leaving that blank. Okay, so now it's time for me to type the name of the function. The name of the function has to be the same as the name of the class, and the name of the function is going to be date. There's my prototype for our first constructor. All right, let's go ahead and write the function definition for that. So just to be clear, a constructor is just another member function with some special rules and special abilities, right? So the same pattern for typing the function header that we used before still applies. I thought I had saved it, but I haven't. So let me do this again. Return type, space, name of class, colon, colon, name of function, parameters. Okay, there's the pattern. Hopefully this pattern, typing this out, makes sense what I'm doing there. What I'm saying is that now in order to actually create a function header for a member function, I'm just going to type this pattern, except every time there's angle brackets, I'm going to replace it with whatever the angle brackets say should go there, right? So the first thing I need to type is the return type. I leave that blank. There is no return type. Next comes the name of the class. The name of the class is date. Next comes colon, colon. Next comes the name of the function. The name of the function is date. Open paren. Next comes the parameters. There are no parameters. So I'm done. There's my header. Okay. Students sometimes get sort of befuddled on these function headers because the word date can appear more than once. So that's why I'm sort of beating it to death a little bit. But I just want you to see that you're just following this pattern. And don't even think about whether you're typing the word date twice or 3 times or 7 times, right? Just follow the 4 items that are needed in the function header. Okay. So just for fun, a little more informal. You wouldn't normally actually do any output in a constructor, but just so that you can see what's going on here, I'm going to just have the constructor print a message. Hi, I'm the constructor. Okay. How many times is this phrase going to appear in our output? Here's main. How many times is that phrase going to appear? So here I am declaring a date object, right? So that's 1 time. Here I am declaring another date object. So the constructor is going to get called again. Okay. And then it actually turns out that we declare a date object in our increased by function too. So because I've called increased by 1 time from main, this is going to result in a 3rd time that output comes out. Okay, so let's just see that in action. Oops. Delete. Actually, this comment is out. Okay, so there you see that's from declaring date 1 back down there in main. That's from declaring date 2 back down there in main. And now I'm going to go ahead and enter a date. And you can see that the hi, I'm the constructor message gets printed out 1 more time because that's when we just called the increased by function. And the increased by function declares the date object, so that causes the constructor to be called. Any questions about how that's working? And what I'm going to do next is I'm going to show you how it can actually be useful, right? I haven't showed you yet how it can be useful. I'm just showing you the mechanics of it at this point. Any questions about the mechanics? Okay, so what we typically use a constructor for is initialization. So without my constructor, if I were to say right here, see how when first declared date 1 equals colon date 1.print, see how end up. Anybody want to predict what is going to come out on the screen for date 1?
Junk.
That's exactly right. Just going to be junk, right? When first declared date 1 equals garbage. Okay. So what we're going to do is we're going to make it so that dates get a default value. I'm going to say month gets 1, day gets 1, so January 1st, and then for the year, I'm going to put 1600 because the calendar we're using here didn't really exist much before 1600 anyway, so it doesn't really make sense to go back any further than that. And so now If I try it again, when first declared, date 1 equals 1/1/16. Okay, so at this point, the use of a constructor is that your objects will be initialized to some default value. Okay, that's still not like they're really required. We could live with objects not being initialized to a default value. I mean, after all, that's how we work with integers and chars and all those, right? If I declare an integer, it doesn't get initialized to some default value. It's just garbage. We could treat dates the same way. So at this point, the use of constructors is kind of nice, but it's not critical. So in a couple of weeks, we're going to see situations where if we don't have constructors, our class just doesn't work. Okay, so hold on that one, and we'll get there soon. Any questions about that constructor? Okay. You can also allow the user to provide the initialization. So I could say something like this. Okay, this syntax may look a little strange at first. It's sort of a weird hybrid of a declaration that looks sort of like a function call with arguments, right? So you kind of have to get comfortable with the fact that we're kind of combining two things here. This is a declaration, but it's also calling the constructor, and it's sending these three arguments to the constructor. So in order to get this to work, what we need is a constructor with 3 parameters. Now, we've talked about function overloading before, but not much. So just to be clear for everybody, in C++, you can have 2 functions with the same name as long as the parameters are different, right? Because if the parameters are different, the compiler will decide which function you mean based on what the parameters are. Okay, so not the first time we have seen function overloading. If you did it correctly, you would have overloaded the toUpper function in assignment 6, right? Because there's already in C++ a toUpper function that takes a char as a parameter. We wrote a toUpper function that takes a C string as a parameter, and that was fine. We could have 2 different functions with the same name. Okay, so I'm going to add another constructor here. Again, no return type. Name of the function has to be date, 3 parameters. Go down here to define the function. Date, colon, date, int, month, int, year, int, year. And then I'm just going to set the month data member of the calling object to in month, the day data member of the calling object to in day, and the year data member of the calling object to in year. Okay. I think that's good. I think we should be able to see this run now. And oh, well, what we need to do here is print out date 2 so we can see that it got initialized to February 28th, 1976. When first declared date 2 equals date 2.print. So let's check this out. When first declared, date 2 equals 2/28/1976. Okay. All right, I think that, one more thing I want to say about constructors. This constructor here that has no parameters is called the default constructor. So you'll probably hear me use that term, so you'll need to remember what I mean. Just the constructor that has no parameters. And we call it the default constructor because it's the we call it the default constructor because it's the constructor that gets called if we don't provide any arguments. We just declare the function, the date object without any parameters after it or arguments after it. Okay. All right, so I think that's all I have to say about constructors. So that's one of our 3 logistical details down. The second logistical detail we have to talk about is this. It actually doesn't make, it decides which constructor. Hold on, sorry, I missed something there. Yes, that's correct. It decides which constructor to call based on, based on the parameter. So it could be the number of parameters, but it could also base that decision on the types of the parameters. Okay. Technically speaking, it decides which constructor. So technically speaking, when the compiler sees overloaded functions, as in this case, it decides which one based on what we call the signature of the function. But basically the signature of the function, for our purposes right now, it's fine to just think of it as the parameters, right? The signature does not include the return type. So if the only difference in your functions is the return type, that's not going to work. All right, but that's a level of detail that I wasn't really too concerned about having you understand at this point. If you're on overload already, you can deprioritize that piece of trivia. Okay, so in C++, when we create classes and use classes, it actually doesn't make sense for all of that code to be in the same file, right? For example, when we use the string class, we would not expect that every time we want to use the string class, we have a file that has our client program in it and also all of the code from the string class in it, right? Instead, what we do is we just # include string, and that gives us the class, the code that we need. Okay, so the way that this works is that every time I say to you, okay, I need you to write a class and also a client program that goes with that class or that uses that class, you're going to be giving me 3 files. And those 3 files correspond to, let me bring that up here. This picture, if you remember, we've got our client program on one side, we've got our class implementation on the other side, and then we've got this wall of abstraction, which is the specification, is going to be in a 3rd file. Okay, let me just be clear about which parts of the code we just worked on correspond to each of those 3 parts. So we've got a client program, we've got a specification, and we've got an implementation. Probably pretty clear that this is the client, right? Just so you know, a client can have more than just a main, right? I could have 100 other functions above int main here or below int main here that are still part of the client. Just like you've written programs that have many functions in them that are clients of the string class, right? But in our particular case, we haven't created any other function, so it's just main. That's the client. That's going to go in the client file. The definitions of the member functions, that's part of the implementation. The client programmer doesn't need to know anything about that. Okay, so all of that stuff is going to go in a separate file called the implementation file. And since I've got that selected already, I'm going to go ahead and just cut that and paste it into a new file. Okay, and this file is going to be the implementation file. And by convention in C++, we name the implementation file name of class.cpp. Okay. So there's the implementation file with the implementation in it. And then this stuff here is the specification. Now this gets a little confusing because technically this stuff here in the private area, that is not part of the specification. That's part of the implementation, right? I could change how I implement a date. I could say, oh, well, instead of having 3 integers, I want to just have 3 string variables or 2 strings and an int, okay? And I could change that and my client program would still work. That's really important. So these 5 lines here, the private part of my class is part of the implementation, but just because of how syntax works in C++, we can't take those out and put them into the implementation file. So we leave them here in the specification file, even though that's not ideal, okay? So I'm gonna take this code out of here, out of the client file, and create a new file for it. And this is going to be our specification file. The specification file in C++, the convention is that we call it date.h. So name of class.h. So really, C++ programmers almost always call this thing the header file instead of calling it the specification file or the interface file, right? Not as precise of a term, but it's what most programmers actually use. That's the terminology that most programmers actually use. Okay, so we got 3 files. Let me say a few things now about what we need to do to connect these files together. Okay. In the so in your IDE, you're going to have a project. Your project is going to contain the implementation file and the client file. Okay, so that's how we're going to know, that's how the project is going to know to compile and run both of those files. They're going to be in your project. The header file, and this is a little confusing, but it does not need to be in your project. It's getting added literally, like physically, this code is getting copy and pasted into the other 2 files because we're going to have a # included. So the header file does not have to be in your project. However, usually we put it in there just because it's easier that way. You know, if we need to edit it, we can just double click on it, whatever. So you'll see it there, but it's not required. Okay. So that's point number 1, I guess. Point number 2 is our implementation file and our client file are both depending on this code. So at the top of them, we need to include it. So at the top of my temp, of my client file, I'm going to say # include date.h. Because it's a programmer defined header file, we use double quotes instead of angle brackets. Same thing with my implementation file. None of this code will compile by itself. It needs to know that there's this class called date. And then we also need the usual stuff up here. Whoa. Okay, any questions about what I'm doing here? Top of the implementation file and top of the client file need to have the # includes and the using namespace. Okay, so now let me say this about organization, okay, and this is important. I don't think I have updated this recently in the lessons, so what you see in the lesson may lead you astray a little bit. What's important here is how you add these to your project, okay? You should be, and I apologize, I haven't used Xcode in a long time, so I don't remember exactly how it looks, but it's going to be a very similar process, okay? If you're using Visual Studio, what you're going to do is you're going to right click in the Solution Explorer, there's a source folder. You're going to right click on the source folder and you're going to say either add new item. No, you want to say add new item. If you say add existing item and then you go find it, it's going to be potentially confusing because it may not save it in the right location. So choose add new item, and then you can just copy paste this code into the file that pops up. For the header file, because it's technically doesn't need to be part of the project, instead of adding it to the source folder, you're going to add it to the headers folder. So there's a folder in your Solution Explorer that says headers or something like that. And you're going to right click on that, add new item, and then add the header file like that. So the key thing I want to say is add new item is your friend, okay? You know what I want to do is just, I have a feeling like this, I've thrown a bunch of stuff at you just now. Might feel a little overwhelming. Probably it's going to be helpful when you get to go to lab and actually try this out. But let me just bring up the lesson real quick here. Oh, it's not posted yet. Let's see. Up into this. Okay, so lesson 15. So I have this in the lesson. Let's just go through it and see if it makes sense or see if I want to change my mind about anything, okay? So here's the 3 files. The file that contains the client program is called whatever you want to name it, .cpp, must be added to the project, just the way you've done all of your files so far. And it must # include the .h file. Okay. Then you're going to have a file that contains the definitions of the class member functions. This is by convention named date.cpp. It must be added to the project along with the client program using add new item. Must # include the .h file at the top. Okay, we call this the implementation file. Then you've got the file that contains the class declaration. By convention, we call it date.h or name of class.h. It's typically added to the project in a folder named header files or something similar, but technically does not need to be added to the project since it's # included by the client program in the implementation file. The only other thing I would say about this is that when you add it to your project, you're going to want to say, right click on the header files folder and choose add new item. Okay. What will happen if you add it some other way is you are likely to end up with files that are in the wrong location and the project can't find them. Okay, anybody want to ask a question about any of that? I realize that the stuff about splitting it up into 3 files, there's nothing conceptually hard about that, but it's a lot of mechanics that can get confusing just because there's a lot of it. So if that turns out to be the thing about this assignment that's difficult, please don't waste a bunch of time on it. Just get help, get it figured out, and you'll be fine. Much more important that you understand the stuff about actually writing the code. In fact, if you get stuck trying to split it up into 3 files, just leave it in 1 file until you have a chance to talk to me or Kyle about it, or a tutor or whatever. And then don't worry about splitting it up into 3 files until you get help. Okay, one other thing we need to talk about when it comes to header files, and that is in about 3 or 4 weeks, we're going to come to some situations that are more complex. You've got a bunch of header files and a bunch of implementation files floating around, and you can come up across a situation where you'll have the same header file # included twice. And so the compiler will complain and say, wait, you already declared this, you can't declare it again. So what we do is whenever we have a header file, just automatically, we are always going to include some code to prevent it from being included twice. The way that works, and I think, for the most part, I just want you to think of this as a magic word that gets the job done, okay? I can explain a little bit about what's going on behind the scenes, but it doesn't really matter if you don't understand it all at this point. You just need to know that you have to type if and def, that stands for if not defined. And then you're going to put all uppercase, name of class. Oh boy, my keyboard just died on me. All uppercase, name of class _H. What goes there doesn't have to be date _H. That's just a very strong convention in C++. So let's go with that. Next line, # define date _H. And then at the bottom, you're going to say # define. You're going to say end. Okay. That's all there is to that. I'm going to take 1 minute now to try to explain a little bit about how that works. But I just want you to know that if you get lost in the next 2 minutes, it's okay. Just follow the pattern. Basically, when I put the # in front like this, that means that these are directives they're called preprocessor directives that are being executed as the file is being compiled. So it's not being translated into machine language like everything else. It's being executed while the compiler is working at translating this into machine language. And so the compiler comes along and it sees this and it says, okay, I'm in the middle of compiling this code. Just sort of over here on the side, I'm going to define a variable named date _H. Or actually, I guess I said that backwards. First thing that happens is I'm going to check to see whether there's a variable named date _H that has been defined. Well, at least the first time I get to this code, the answer to that is no. There hasn't been a variable named date _H defined. So what I'm going to do is I'm going to define a variable named date _H. And this is not a variable like in the code. This is just a variable for the compiler to keep stuff in as it is compiling your code. Okay, and so because date_h was not defined, it's going to define it, and then it's going to compile all of this code until it gets down to the end if, and then it's done with that. So then if it starts to try to compile this code a second time, when it gets to this line, it's going to say, oh, date_h has been defined. So that means I'm going to skip everything from here down to the end if, and I'm not going to compile it, which is good because it was already compiled. Okay. Only thing I haven't done is actually try this. I'm a little afraid to try it because I did a bunch of stuff, and I'm probably going to get some errors and we're out of time, but I'll just try it one time. If it doesn't work, we'll fix it next time. Let's see, we had client pm.cpp and date.cpp. Okay, so when you're on the command line, you have to tell it to compile both of these files separately. Okay, and that's the same thing that's happening in your IDE. When you say run, the IDE is automatically doing this. It's automatically compiling both of your .cpp files separately. Not client, temp. Oh, look at that, it compiled. Wow, okay, there were no mistakes. Okay, so if you're using the command line, which I hope that none of you are, but if you are, then what you have to do is you just have to do the say to compile whatever your command line command is to compile, and then list both of the .cpp files. Again, you don't list the .h file because that is being # included from these .cpp files. All right, any last minute questions before we go?
Oh, are you gonna upload this lecture on YouTube?
Yes, I am.
Okay, fantastic.
I will do that. I'll probably have to do it tomorrow if that works. If there's something urgent about it, I might be able to do it tonight, but otherwise I'll just do it tomorrow. Is that okay?
Perfect. Did you
Okay.
also upload last week's lecture as well on?
I think I may be a little behind on that, so I'll make sure to get all caught up with that tomorrow.
All right, thank you. I really appreciate it.
Okay, no problem. And I will see you all on Wednesday.